Hi, welcome to this video. In today's video, I'm going to do a very interesting problem of International Mathematical Olympiad of 1977, problem number 4. If we have f of theta equal to 1 minus a cosine theta minus b sine theta minus capital A cosine 2 theta minus capital B sine 2 theta. If you have this condition, f of theta superior or equal to 0, theta is a real number. We have these two questions. Prove a square plus b square inferior or equal to number 2. Another question, we have the capital A square plus the capital B square inferior or equal to 1. So now, before I start proving this one, I'm going to prove these two inequalities. Okay, these two, I'm going to use them as a tool. So I have f of 0. Let's plug 0 into this function. So the cosine of 0 it gives me 1, so minus a. Sine of 0 equal to 0. Cosine of 0 is number 1, so minus a. So 0 into sine gives me 0. So my inequality become this one. Always this inequality is superior or equal to 0, or superior or equal to a. This is, let's call it equation number 1. Okay. Sine of 2 multiplied by pi over 2, which is sine of pi equal to 0. So you'll have this inequality. So this is equation number 2. Inequality number 1 plus inequality number 2. If I'm adding 1 plus 1 equal to 2, okay? Minus a minus b, that's mean minus a plus b. Minus a plus equal to 0. This means superior equal to 0. Equivalent. That's mean a plus b inferior equal to 2, okay? I'm going to, since we have a superior equal to 0 and b superior equal to 0, that's mean a plus b inferior or equal to 0 and 2, okay? This is very important inequality, okay? A inferior or equal to square root 2, okay? So I have 1, 2, 3, 4, 5 inequalities, okay? By absurd proof, we have this, by this assumption, this implies I'm going to divide on both sides. I'm going to divide number b on both sides. So I will have 0 b a plus b 1 over b plus b. So the bottom one I will have always 0 a plus b. Okay, so what I'm going to do now, I'm going to evaluate this one. So I will have strictly inferior than 1 over b plus b. This one equal 1 plus b squared over b. So this one has to be inferior or equal to 2, as you have a plus b here. Okay? Plus b 2. What does this mean? This one. So I'm going to bring 2b to the other side. We'll have 1 plus b squared minus 2b inferior or equal to 0. That's mean, what is this? This is b minus 1 quantity square, okay? b minus 1 quantity square inferior or equal to 0. Do you think this is true? This is impossible, because this one is supposed to be superior than 0, not inferior or equal to 0, okay? This is impossible. Impossible. That's mean this is not correct, this is correct, okay? This is the product of EB has to be superior or equal to 1, okay? So finally, A product AB superior or equal to 1 for all real numbers. This is identity is verified. Now I'm going to verify this second identity. So I'm going to evaluate f of theta plus pi, okay? I'm going to distribute this one. So cosine theta plus pi equal to minus cosine theta. With this sign outside become plus 1 plus a cosine theta, okay? What I'm going to do now, this is always superior or equal to 0, okay? Superior or equal to 0. I'm going to add the first inequality and second inequality to see what's the expression. For the sine, I have minus b capital B sine to theta. With this minus b sine to theta becomes minus 2 capital minus 2 times b sine to theta. Alright? Superior or equal to 0. Okay? What I'm going to this one, I'm going to bring these two terms to the other side. I leave 2 on the left hand side. So number 2 will be cancelled out because I'm going to multiply by 2. So number 2 will be simplified, okay, because all terms have number 2, okay, in the front. So now, f of theta, in this case for theta equal to 0, what does mean? 1 superior or equal to a, because cosine to theta, because cosine of 0 equal to 1. The sine of 0 equal to 0. So that's mean 1 superior equal to a. This is very important too. I'm going to check with theta when theta equal to pi over 2, pi over 4. Okay. So when the theta equal to pi over 4, that's mean this inequality become 1 cosine 2 multiplied by pi over 4 equal to pi over 2. Cosine pi over 2 equal to 0. Sine 2 pi over 4, that's mean sine pi over 2 equal to 1. So you'll have the b here, capital B. So what I have here, I have the 1 superior equal to a, the capital A. I have 1 also superior equal to capital B. But I cannot do the product of these two terms since I don't know the sign of these numbers. Okay, they may be positive or they may be negative. We don't know, so we are not allowed to do any product at this time. So we have to prove B and A are positive in order to do the product. Okay, or at least one of these should be positive. Okay, so that's what I'm trying to do now. Okay. So since this one also, I'm going to put the theta equal to pi over 8 to see what's given us. This is inequality. Now I'm working on this inequality now. So 1 superior or equal to a, cosine to pi over 8 equal to cosine pi over 4, which is square root 2 over 2. Alright? The same thing with the sine, because sine of pi over 4 equal to cosine pi over 4. So I have this one. So this is equivalent. What I'm going to do now, I'm going to multiply both sides by square root 2 over 2. This is very important also. Same thing with the theta minus pi over 8. I'm going to do this. 1 superior a square root 2 over 2 minus capital B square root 2 over 2. I'm going to replace in just minus pi over 8 into this inequality. 1 become minus because the sine of minus pi over 8 becomes sine of minus pi over 4, which is minus square 2 over 2, which is this one. Okay, this is very important inequalities. What I'm going to do now, I previously proved capital A superior equal to minus 1 by using the previous inequalities. Okay. So what this means, I have these two inequalities as well, are parallel with this one. So I have this one, I have also this one. What does mean? I'm going to add the capital B on both sides in first inequality to see what's the expression. So that's mean B minus 1 inferior or equal to A plus B. Okay? This one, what is this? Is this one that I have here, square root is inferior or equal to square root of 2. Okay? So what's this mean? That's mean B minus 1, I'm going to do this one simply. Okay, b minus 1 inferior or equal to square root of 2. That's mean minus 1 minus square root of 2. I'm bringing square root of 2 the other side, and the b to the other side becomes minus b. Okay? I will keep this one on side. I'm working on the other side as well. So since I know this one, right? So minus 1 inferior or equal to a. I'm going to add in minus b on both sides. Okay? As I did before, I add just b. Now I'm adding minus b. Minus 1 minus capital B. I mean a minus b. You know a capital A minus b inferior or equal to square root of 2. As you have before, right? What does telling me? That's telling me I'm going this one minus capital B inferior or equal to square root of 2. What does mean? I'm bringing square root 2. I'm bringing square root 2 the other side. I will have minus 1 minus square root 2 inferior or equal to. I'm bringing also the capital B to the other side. I will have. Okay, now I have ended with two different inequalities. But remember, I have the same number, minus 1 minus square root 2. I have minus 1 minus square root 2 in both inequalities. I have also the same number, but with different sign, okay? That's mean capital B is positive, okay? Now, since I have minus 1 minus square 2, the inferior equal to minus capital minus b, that's mean b is superior or equal to 0, positive, okay? That's what I'm looking for. So now I can tell you what's the sign of the capital A. So the maximum of a plus b and a minus b equal to square root or 2. This is the maximum number they can get, okay? And also we have b positive, okay? B is positive, superior or equal to 0, and a also superior than minus 1. All this information, a is all this information, the capital A must be positive, okay? I can now I'm allowed to apply this product of capital A and B because of this positive of these two numbers, okay? So now, since I know A positive and B positive, since I know B inferior or equal to 1 and A inferior or equal to 1, this implies the product of both numbers AB inferior or equal to 1. Okay? I'm going to prove this second identity. The capital A multiplied by capital B superior or equal to 1 over 2. Okay? By assumption theorem, by hypothesis theorem, I'm going to prove this one. Okay? Since we know the capital AB between 0 and 1, so I have two choices. Okay? Now since the capital A multiplied by capital B between 0 and 1, okay? So by hypothesis theorem, by absurd theorem, so if I find the contradiction, okay? So that means capital AB superior or equal to 1 over 2, okay? So now, what I'm going to do now, since we know these two inequalities, also by assumption, we have this product of capital AB. What this telling me? I'm going to divide the B on both sides, okay? So I will have 0, A, 1 over 2B, okay? I'm going to add the capital B on both sides. I will have A plus B. I will have 1 over 2B plus B, okay? What does this mean? This one. So now, since I get here, okay? So this one equal to 1 plus 2b squared over 2b, okay? This one has to be inferior or equal to square root 2. As you have ab inferior or equal to 2, this is the condition it has to have, okay? So what does mean? I'm going to work on this one, okay? So I have this one 1 plus this one equivalent 1 plus 2b squared inferior or equal to 2 square 2 multiplied by the capital B, okay? As you see, I'm just multiplying this one by this one, and this one b plus 1 is inferior or equal to 0, okay? I'm going to factor this one. As you see it here, this is identity square, so this is one quinary square. So this one, what is this? So this means square 2, okay, b, okay, this one 2 times b square 2, okay, plus 1, which is square 2 b minus square 2 minus 1, okay, quinary square. If you distribute this one, you will get this one, okay? This is inferior, this is strictly inferior or equal to 0. Do you think this is true? Okay, this is not true. This is impossible, okay? This is impossible. Contradiction. Now, because this one has to be superior or equal to 0, okay? Now, what does mean? That means A, capital A, and B superior or equal to 0. The product of AB superior or equal to 1 over 2. Okay, now I proved the second identity. Now the second identity is proved. I'm going back to my question. Now I'm going to answer my question, okay? I'm going to calculate f theta plus pi over 2, okay? So this one by replacing pi over 2 into this inequality to see what's giving us. Superior or equal to 0 always, okay? So now what I'm going to do, I'm going to add the first inequality and second inequality to see what's the expression. So the cosine of theta plus pi over 2, so cosine of theta multiplied by cosine pi over 2 equal to 0, okay? For the sine, I have to have the sine minus plus, with minus, you have to have plus. So for the sine, I will have sine of theta multiplied by sine pi over 2 with sine of pi over 2 equal to 1. So this means a sine pi over 2. This means sine of theta. Okay? For the sine, now what I'm going to do, I'm going to add the first inequality and second inequality to see what's the expression. So what I'm going to do now, I'm going to bring all these terms to the other side. I leave number 2 in the front, okay? So what I'm going to do now, plus a, okay? For the sine, I will have sine theta multiplied by b minus a. Alright? So this one, that's mean 2 superior or equal equivalent. So that's mean 2 superior or equal to cosine of 0 is 1. So I will have a plus b. But sine of 0 equal to 0. That's mean I have ended with this inequality. What I'm going to do now, I'm raising number 2 as a power on both sides, okay? I will write it on the other form as well. So I can write a squared plus b squared plus 2 times ab inferior or equal to number 4, okay? What does mean? I can bring 2ab to the other side, okay? So I will have a squared. I'm multiplying by number 2. I'm putting number 2 as a multiplier, so I will have 2 minus ab. Okay, what is this? This one I can rewrite, since we know ab superior or equal to 1 minus ab inferior or equal to minus 1. Okay, I'm adding number 2 on both sides. So I will have 2 minus ab. 2 minus 1 equal to 1. I'm multiplying both sides by 2. So we'll have 2 minus AB inferior or equal to 2. This one is this one. This one inferior or equal to. Okay? So that's mean A plus B squared inferior or equal to 2 minus AB inferior or equal to 2. Okay? Now I proved the first question. I'm going to clean the board and move on to the seventh question. Okay? The seventh question is easy because we already proved A plus B inferior or equal to square 2. Okay? I'm going to reach the number 2 as a power on both sides. So I will have A plus B square 2 square with 2 square. So we will have A plus A square plus B, which is A square plus 2 times AB capital plus B square inferior or equal to 2. What I'm going to, so I'm putting A square plus B square and bringing 2AB to the other side, become 2 minus 2AB. Okay, I'm multiplying, I'm putting 2 as a common factor, so 1 minus AB. Okay, AB superior or equal to 1 over 2. What does mean? So that's mean minus capital AB inferior or equal to minus 1 over 2. I'm adding number 1 on both sides. I will have 1 minus 1 over 2, which is 1 over 2. Okay, so I have now, I have 1 minus AB inferior or equal to 1 over 2. I'm multiplying number 2 on both sides. So we'll have 1 minus AB. Okay, inferior or equal to 1. Okay, that's it, I finished. So this one, we have A squared plus B squared inferior or equal to 1. Okay, for all real numbers is superior, for all real numbers A, for all real numbers A and B superior or equal to 0. Okay, I have done with this one. Now, this is a good place where I can stop. Thank you for watching. I will see you in next video. Bye.